Just I don't want to blur it out right when you do it. Just send me the link so I can open the window.
It's too late. So the link is in Discord. Welcome everybody to the Friday Marble Machine CAD team stream. I've got David Lewis on video here. We also have Andre. Say hi, Andre.
Hello.
Who is on Discord, and we'll be looking at his screen from time to time. Where the heck is he? There he is. So we have SolidWorks going, and we are also going to be going back and forth into Fusion. We're going to continue the Marble Machine, the Winter Garden Music Box project first, and then we're going to, I think, start. After last week, we kind of got, at least I got comfortable with the skeleton concept, or the way that David had kind of laid it out, and so we're going to try doing that for the actual Marble Machine. So that is what we're up to today. Let's see. So first, what did we call this guy? The Marble Machine.
You mean the music machine?
Yeah, the music. The music box.
The current one was MB2.
Was that the one? That's the one. But I think I forked it.
Maybe you did. I don't know.
Or I tried to. I guess the one that's February 25th. So no one has played with these since last stream, which is fine. MB2. This is one of the things I really have a hard time with this file system, is that where are my sorting options? How do I? There's no folders. There's just everything is flat, and everything in. Well, I guess we have a music box project, and we can pick different ones.
Well, I think they're trying to encourage tagging with the 6 Ws so that everything is really flat where it's saved, and then it's just, if you've tagged it properly, we wouldn't have this problem.
Right. Yeah. So these guys, box MB2. I'm just going to open this guy.
I might need to close it if you want, because actually I have that open right now.
Oh.
Let me close it.
Well, what'll happen is that it it will open and read only. And I don't know if I can do it just because I have the master account, but when I opened your file and it still had you reserved, you saw the reservation. I was able to just take it from you. I was able to just grab the files from you, which was cool.
You want to try? Go ahead. I can close it otherwise.
No, it's okay. Oh crap! It's making me enter my password. This whole thing with I'm on a crap. I can't talk and do this at the same time. It doesn't always remember your login credentials.
Oh, we got a little bit of echo right there.
I will turn this down. How's that?
Test. Okay, I'm not hearing myself.
Okay,
seems
good.
Positive.
Do you want to? Am I echoing at all?
No, you're good.
Not me.
Okay.
Man, I can just figure out how to do this tagging. We did it before, but now I don't know how.
Yeah. So, quick note to self: log into SolidWorks before you start the live stream.
Yeah, dude. Oh, bookmark editor. This is it. It's got to be it, right?
Yeah, but how do we actually use it?
Yeah, it's a good question.
I know that we went through when we had Sean O'Neill on the line, and we made a bunch of bookmarks. But how they actually apply and how you apply them to a part was beyond me. All right, SolidWorks. There we go. SolidWorks is open now. Yippity doo dah day. All right, so this is the one that I did, and it doesn't show that it's reserved.
Add
is nice.
existing content.
Does it show that I've reserved it? Because whatever that is behind.
No, I mean it's read only, but I can come over here and select all of these. It's behind your face in left screen. I'm going to remove your face from the stream for a second. So it shows here that it's unlocked. So I could select all of these and hit reserve. And oh no, it didn't. It
let
just
me
gave me an error
unreserve them
saying
and
that
see
you
what
have
happens.
it.
Yeah, let me unreserve them. See what happens.
Okay.
Okay, I have unreserved them.
But it should. Oh, look, that was weird. Like some part of your geometry just showed up for a second.
Yeah, I have a few things open, but not much.
Anyway, the post, after last week's stream, I did play a little bit around with this file. I was able to put in the new equations for the. I do miss that. I guess you have to hit the space bar to get it, don't you? I'm going to say I missed the view cube, but then I realized that we have a view cube. I put in all the key parameters for the motor driving section, the two different pulleys, and all that stuff. And I've just remembered that I need to keep this thing open so that if we have some comments, hey, we do have people here. If we have some comments, hey, we do have people here. Welcome everybody. Welcome everybody. So we have that. We have the soundboard, but I actually kind of want to already kind of go in and change the assumptions here, because I've had this idea, and this was because Tom Nelson, shout out to. So there's an interaction between him and Martin on the Discord forum because he posted him playing. Tom, can you type in the chat? Tom, can you type in the chat? About 5 seconds delayed echo.
Well, I think he's commenting on the sound delay from seeing you. I don't think there's any echo. At least, actually, I'm not even listening to YouTube, so I don't know if there is.
Yeah, I hear a little bit of an echo. But then again, I should probably just mute myself on YouTube. That's probably what was doing. Is I was anyway. So,
by the way, did you want me off camera still?
No. I want you on camera. I just took that away because because I needed to show this flyout window, which was right behind your face.
Right. So, sorry, that's right.
There's no winning here. Sorry. It was. What's cool is that we know with these new. I'm going to sound so old right now. With these new computers, where you can be running YouTube and OBS and all these different things all at the same time. Like there's all these audio sources, and you just have to figure out like all these. Anyway, it's cool that the computers can multitask like this, but it's difficult. So let's go to Discord, and Tom, I'm gonna restream. I hope you forgive me your Marble Machine. Marble Machine. This is not the right one. Got Team Music Box. Where did you post that? Here we go.
Before this begins, I just want to let you all know that this is a work in progress music box. It's not finished. This is just the first song.
Maybe I should
it
check
will
this
be,
out on YouTube.
Motorized just like Wintergothen's
video URL.
music box. There
Hold
will
on,
be build
pause.
videos about.
I'm gonna figure out what the hell I'm doing eventually. There we go. All right. Oh, not Tom. Oh, that's Dan. I'm sorry. I got you two mixed up, Tom and Dan. Sorry. So this is. Can you guys hear that?
It's because I am not listening to the YouTube stream, but if I was, then I could.
Mm-hmm.
Yeah, same here. But I've seen this before. It's actually really nice.
Yeah. So I mean, what's amazing to me is the slight differences in timing of the notes makes a big difference, right? And there's a lot of kind of inflections in the playback, like the do 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 do, like there's emotion conveyed, right, by that timing, right? So even that you're manually punching out, the holes for the notes, like, I think it's impressive, not that only that someone can build a machine to do this, but that also you can punch out the music, right? But then the Discord +2, the thing that kind of made me think of this was in the thread here, Martin said, did you get pain in your fingers from cutting the holes? and then talking about such a special pain that so I was thinking, so we talked about the people who made machines to punch these holes, and we're aware of one. I'm gonna stop this. We're aware of one that that Sebastian did, where he was laser cutting the paper, right? And then there's someone else who did, let's see, music box punching machine, paper punching machine. There we go. Is that it? It may not be. It may not be.
Correctly and lined up.
This isn't the one I was looking for.
You don't have to do any post-processing on after it prints.
This is somebody else doing it.
Automatically, you get everything in view.
Machine to accept shorter or wider strips of paper, you could easily just change some variables around and get it punching whatever kind of music box paper you want.
Yeah. So let's take our text file, put it in our
Let's see, music, paper, punching,
and get punching.
MIDI file to music strip. This is funny. Someone's using a Cricut for it. You see that?
Like an insect.
No,
Can you hear?
A Cricut? It's a vinyl cutter for that you can for like paper crafts and stuff.
Yeah, yeah.
Yeah,
That is interesting.
This is the one I was looking for. So let me go through a little bit.
Hey, I had a network anomaly. Can you guys hear me at all?
I can hear you.
I can hear you.
Okay, cool. Because I've been asking for the last minute. Nobody responded. And also, your YouTube stream sort of died, and I thought it was you, but actually it looks like it was me.
It being on your side would explain everything. Nice. So you see this thing? This guy's got a servo motor that's feeding the punch. He's got a drive system, and it looks like it's going forward a certain amount, and then the punch is traversing the paper, placing the notes.
There's just like a drill bit in there.
Oh, you're right. It is a drill bit.
So weird.
I'm wondering, is there an anvil on the other side, like something to push stuff through?
Yeah, there has to be, right?
It would have to move with the bit, unless it had a series of holes in it in the right spot, which I guess is likely too.
Well, no, you see.
That is weird if you can drill bit though.
Oh look, well, no, that's a mounting hole right there. Let's see if we can take a look at it before he plugs the stuff in. Mario, that doesn't show the other side.
Top secret technology.
He's even got a little thing for yeah. Well, I mean, you can see there that right. This red carriage is a C-shaped. Right, so it can go all the way across, and you probably have the other side of the punching mechanism here, and it can just go back and forth. Right, so
to anyone that survived the 2000 election, I'm scared away by this thing.
Dimpled chads, etc. Is that your concern?
Well, I mean, I'm naturally suspicious of any chads in general, but of this one in particular.
Yeah. Yeah. Well. Anyway, so the idea, right, between those things, between this this thing that Dan had made and Martin. I already thought that I already knew that the punching. Crap. Here's another one. ADD in effect. I can't even finish a sentence before squirreling to another YouTube video. Holy crap! What's this person doing?
Wow, this is pretty impressive.
What? What the hell?
Insanity.
It's probably
it's like firing them out. Sweet.
Yeah, like a punch from the bottom.
Yeah, well, but look, I mean, so he's got all of the different holes. Right, so probably he's staggering them across, so all the different combinations, and he's doing
those rollers on the right though are straight for CAD.
That's insane. That's like, I don't know. That's like the hardest way to do it. Like if you said like, hey, what's the hardest possible way I could solve this problem? I mean,
he's actually playing it too. Like, I think he's...
wow.
Look at all the airlines, though. It's clearly some kind of pneumatic system.
Yeah, I mean, I think each note has its own... Like, if that's a 20-note music box, he's got 20 pneumatic lines right there.
Wow.
Which means you need to have 20 solenoids, right? I mean, maybe this person's like a pneumatics engineer, and so, you kind of do what you... Oh, yeah, look at this. Well, that's his valve terminal.
Oh my god!
From Festo, so it's expensive. I built a big laser engraving machine using mostly Festo pneumatics, and they're great and easy to work with, but not cheap. Oh yeah, look at all the stuff in his shop back here. He's got a nice background, but over here, this is some sort of industrial. He's got like a press and die kind of factory thing going on.
Yeah.
Yeah, I mean, you can sort of tell that's like his game, because I mean, you could just see that. Like, if you look at the follower or the thing, I guess the pulling mechanism, that's basically built just like a like a punch or a die.
Yeah, like a press and die with
the guides and everything.
Yeah.
That's neat.
That is super cool. Yeah, look at those. Those are punch sets. So this person knows punches. And now he's going to play it.
Is he playing it? Oh yeah, look at that. I mean, I can't hear it, but...
Yeah. Wait, how's that getting fed in there, though? The hand crank is not operating.
He's got to have a secondary puller someplace.
You can see that the gear train has been removed. There's no gears there.
Yeah.
Look, it's on like an injection molding machine. See, there's like over to the left. There's like it's on some piece of. I wonder if this is Chinese. It's got the red background with the stars.
Yeah, maybe. I'd like to see the rest of this. Obviously, whatever's pulling it through is clearly also important.
You can see a lead screw over on the right-hand side.
Yeah. It's got a little boundary mic.
Right there. It's on a lathe. No, it's a conveyor. It was That
Holy
was crazy.
crap.
All right, I need to stop cruising YouTube.
It's some kind of linear motion device. It looks like it moves a pallet from one place to another.
Yeah.
A linear axis of some kind. It's
Some insanity.
Oh, maybe that's how he's playing it, just moving the linear axis.
Yeah, he was. He was pulling it through.
I didn't actually catch that part of it, but wow,
Yeah,
that's
there was
cool.
there was a big Acme lead screw in there.
Yeah.
Anyway, the oh, I hate this. I have to when this layout, when this is on my left screen, I don't get my full flyouts. But anyway, the idea is, so we have this layout for the music box, and we have the soundboard right here. The idea is to make it so that there's a bass roughly here, and because right now the soundboard is on vibration isolation pads right in this gap, right? So the idea is that below this bass, the actual top of the box below is like, oops, I'm trying to use Fusion shortcut keystrokes in SolidWorks, and that doesn't work. So the actual.
Are you left-handed or right-handed?
Huh?
Are you left-handed or right-handed?
I'm right-handed.
Okay. Do you have your mouse gestures enabled?
I do, but I don't know. I actually can't find, and don't distract me, David. But yeah, I actually can't find where you can edit that menu. I know you can, but I can't find where you do that.
Okay, well, I mean, I can show you sometimes.
Yeah, but
whenever
show me, and maybe even today, just not right now because I'm having a hard enough time concentrating. Carrying a thought all the way through. So the idea is that we would have this base, this lower rectangle is the top of the box, and this lower base that's below where the vibration isolations are, is something that can be, it's on basically 2 pins with some magnets, and basically you can drop the music box in with the vibration isolation and the soundboard, whatever, but then you can take that whole plate out and you can put in a paper punching mechanism, right? And we can connect using header pins electrically between the two, and the same Arduino could help with this secondary functionality. But then you basically have this thing, because the thing that this machine already has, if you wanted to build a paper punching robot to write songs, you would need a spool to handle the paper roll as you're feeding it out. And you need a precise pulling mechanism, both of which we've already provided with this project. So the idea that we could have a separate tool that swaps in, this plugs in, and now you can do punching, and you can send your paper through, then you can basically pick off that module, put it in the soundboard module. It's already isolated. It's just literally like a snap-in, held in with some 2 locating pins and some magnets. And then you can play. I think that's a cool kind of functionality to try to add to this. And I'm always thinking in terms of commercial viability for something. And I think that would make it so that a machine like this would be more accessible to more people, because you could just give it a MIDI file and it would write your music, and then you could play it back. You wouldn't actually have to learn the art/craft of doing the punching.
Andre, by the way, my condolences.
On what?
All I did was dimension a circle. Sweet.
His SolidWorks crashed.
Oh.
Yeah. Okay, let's give that another try here. By the way, I did a bookmark, which is nice. I think I'm starting to figure out this whole bookmarks thing.
So, on the SolidWorks crashing note, that I installed SolidWorks Premium the day before yesterday, or was it yesterday? And I did that after wiping the hard drive and reinstalling Windows, and then not updating to the absolute latest and greatest version of Windows 10. And so far, it seems to be working like it's supposed to. I'm almost ready to say SolidWorks Connected could probably be substituted, but I don't want to stare a gift horse in the mouth if they're going to give me
Right.
regular SolidWorks. I'm gonna keep it.
Right.
Mm-hmm.
Right. Cool. So, I don't know. What are you guys' thoughts about making a modular music box?
Well, I think that's a great idea.
I
think that's awesome. I think it'll make it bigger if that hurts it at all.
Oh well, that's a good question. Let's do, since we're playing with skeletons, let's try to lay it out. If it was right in this location here, I know I already undid. I intentionally saved that without exited without saving.
Right. Just remember, as I'm seeing you do this, that this layout is really for like macro level kind of ideas,
right.
Like where something's going to be in its general envelope and its location, not necessarily how big it is or how wide it is, you could, but I would caution against making this sketch too complicated.
Okay.
I would say that the paper pulling mechanism that you have started is veering actually probably well past being more information than you should be putting in the layout sketch.
This guy right here, you're saying that's too much information.
Is that one block?
That is one block, yeah.
Yeah. So really, if you think about it, the block is for locating the subassembly or whatnot, and for doing things like sizing belts and locating where that shaft is going to be. But if you think about it, like those two pinch rollers can be fully, like all the information you need for this level of sketch is like the diameter, which actually we are representing by that midpoint line that I included earlier.
Right.
And like where those 2 points are. But you don't need more than that in the layout sketch because really you've already defined everything you need to locate them. The diameter of the circle, about how big they are, that information exists in the the equations, and you can draw from that when you actually make the circle in the sketch.
So trying to I was trying to lay it out because we had looked up and we'd done some math on what the length of the belt is, right? And since we're going to end up with a gear reduction, it was going to be just not just a slot entity, but two kind of a slot with it was a belt path.
Is this 630?
This is 630, yeah, right there.
Okay.
And in the layouts environment, you can't use a path length function, and you can't do slots, for example. So, it's kind of like, okay, well, if you're going to do this for laying out belt lengths and locations and kind of making those higher level things, the fact that in the assembly, in the layout view, you can't use those tools was a little frustrating.
Right. Well, still, that just means that might not be critical at this level.
Right. So you would be doing something one level higher up than that.
Yeah. So we're placing the puller rollers because that's what the rest of the machine touches. Right. So that needs to be laid out in relation to where the music box reader is. But the belts that power those rollers that's a function of something inside that particular component or part level.
So we might lay out the roller sizes and diameters, but really not any of this.
Yeah, all of that can be done once you're in the part, if it matters.
Yeah, okay.
Now, if there's a lot of interaction, then that's something else altogether. If the middle of where that belt is supposed to be in the motor matters at this level, and I don't know, based on what I'm looking at, I don't think it really does.
Yeah, no, I think that's right. That could be a downstream kind of decision. Well, we're gonna get that, right? I mean, if we try to lay out the actual marble machine X today, then you know we're gonna come across those kind of questions, right? We're gonna be asking those kind of questions. But let's stick with just like the general concept, right? So if we have this plane here that I have highlighted is where the paper comes through, right? It's tangent to these rollers. So the punching mechanism needs to be something that comes through that. There needs to be an anvil kind of right underneath it. There needs to be some sort of mechanism at the top for actuating the punch up and down. And then there's going to need to be some like a linear slide thing, right? Would you do that with maybe like an IGUS bearing going? You guys seen those? The IGUS kind of I'll show it.
I mean, like those rails that are on like on a cylinder that's up on a foot or something like that.
Yeah. So these things, it's a linear motion system. They use extruded aluminum carriages, so it's not like a steel, linear motion carriage, which are super expensive and there's precision ground. It's like if you don't need that kind of precision, which most applications don't, and then they have these bearings, which are I think triboplastic. It's basically lubricant infused, but still very durable plastic, and they just slide instead of using. So it's inexpensive, and if you have something, I know a lot of people who've put these things on 3D printers, or these guys actually make just polymer 3D printer bearings that are just sliding, and they're way quieter.
That's interesting. I haven't heard of those being used for 3D printers.
Yeah. So, but anyway, they have these profiles like this. This is a cool little double rail carriage, and I'm actually using this on a machine I'm designing right now. And you can just slide back and forth. So, if we had something like that, those things, the smallest they get is 40 millimeters from point to point. So between the rails. So if we look at what that looks like here. Oh man, I've been working in Fusion for the last couple days. And so now my SolidWorks habits are suffering. It's like walking in, chewing bubblegum. That already looks too big.
Speaking of Fusion, there was a decent upgrade, by the way. The March 2021 update.
Mm-hmm.
There was I can't remember what feature it was. Shoot. But whatever it is.
Little icons when you're opening a file. I don't know if that's new.
Yeah, that might have been one of the big ones. Yeah. But whatever it is, it seemed like they're on the right track.
Mm-hmm.
The way they're updating things. And it was kind of cool. My old friend Trent narrates them now, which is kind of neat. I used to work for the guy.
Nice, that's cool.
So, yes. So we need this horizontal carriage thing going back and forth, right? And then we need some sort of actuator for the left and right. It's got to have a stroke of at least 70 millimeters, right?
Yeah, I like the timing belt kind of scenario.
You wouldn't use it like a lead screw or something like that?
Yeah, I guess you can buy those separ motors that have the lead screw built into them, which are pretty good, because then you don't need to have a coupler using up all that precious real estate.
Right. So then we'd have I think Pololu makes those. So then we would have a stepper motor over here someplace. And actually the same people, so this is IGUS also makes lead screws.
I have to admit, I don't know that I've really ever heard of this company before, but that's cool.
So I I found them at a trade show, and I flipped out when I saw what they do because I've been building. I had been building and like material handling and inspection equipment for my last startup, and we had kind of accidentally developed a product that ended up being really popular, which was laser engraving the top of wine caps. And so, I had to basically invent my own machinery. That's kind of like where I went from a winemaker to a business school student, started a company, and then became kind of an engineer inventor because I was just solving problems that I had no other way to solve. Right. And I found these guys in Vegas at a trade show, and I flipped out because all of this stuff is normally so expensive, and this stuff is durable, it's self-lubricating, it's and it's inexpensive, which is great.
Brad,
Yeah,
I'm actually starting to think I remember them now. They dropped off like a sample pack of bushings and all kinds of stuff at a company I used to work for. The orange is their logo is starting to ring a bell now.
yeah. Well, they make all these things, but see this little these are basically their proprietary plastic, which is has basically it's super slippery and it's got lubricants built in. And I got a sample pack and like I just fidget with them. They have high pitched lead screws. Anyway, so I think something like this. Maybe we I'll put something together from that. And to respond to Joran in the comments. So Joran, the machines I was talking about, I had a company called Vin Perfect, which was in the wine packaging business. I invented a way for wine bottles to get exposed to really small amounts of oxygen over time, which they need to do. If you're a wine consumer, you'll see that screw caps are mostly on white wine bottles, not on reds. It's because the screw caps actually are too tight for wine's purposes. Wine needs a little bit of oxygen to breathe. So I invented that. And then I started a company around it, and we ended up being our own manufacturers, which ended up basically killing us. We grew too fast, got in upside down. It was super expensive to run the company. But what I'm doing now, the project I was just talking about, where I'm using these things, I think I can't talk about it yet because I'm under an NDA. But I'll say it's a medical device robot that has a handling feature, and it's going to be a T-bot, so it's going to have two belts driving two rollers, and it'll go left, right, up and down, and it's a handling application for I can say it's analytics in laboratory side medical device used in hospitals is what I'm working.
Cool.
But anyway, so I'm a fan of these guys, and you can actually get this stuff through McMaster-Carr. They don't call them IGES bearings in McMaster-Carr, but I bought like a slewing ring set for a robot that I built once, and it came and it was IGES. I was like, oh, okay, that makes sense. Anyway, so yeah, so I think if we have a stepper motor with its own built-in lead screw, and we don't have to have a coupler, that's the lead screw. We figure out how to hang that off there, shove the carriage back and forth. I think I can put the lead screw actually underneath here, kind of in the space between those two rollers, and then it won't interfere with the punch anvil, which would be right up. Sorry, this is the anvil of the punch, right? So, are you guys tracking, or am I like totally like off on left field?
You're not totally off in left field, but I'm you're looking at the side of the machine, right? It's going left and right.
Yes, yeah. So this whole machine, you're looking at the two. This guy and that guy are the two sets of a linear rail system that's telescoping towards you in the z-axis, right? And so that which would drive the punch across the machine back and forth. Right?
Got it. Okay.
Yeah.
Yeah, I see what you're talking about now.
So we'd have to hang a motor kind of off the side of the machine. This thing would definitely, this module, if you have this thing plug in, I'm gonna just make that right there. Why can I not talk and dimension at the same time? This thing would go back and forth, and the stepper motor would be kind of off to the side. But anyway, so that's the idea: is we have a plug-in module that can punch music, swap it out for the music box, and then this whole project becomes a punching and playing solution.
You'd have to sync the paper pulling motor, to the punching mechanism.
Yes. Yeah, I think basically because we already have to control that motor pretty accurately for the pulling mechanism. Well, in the pulling mechanism, that's all it does, right? So basically, we're developing a punching machine, which is a lot more mechanically intensive, and then we're reusing the puller for the play mode.
Yeah, I get it. So yeah, that's really what we're doing. The play mode is sort of a side benefit, really, to this whole thing.
Yeah, it's much simpler. Yeah, so I mean, again, this is ADD engineering. I think I named the channel perfectly because we're going squirrel. Like, let's do something a little more interesting. But that's the anyway. That's the idea, right? So I haven't kind of with the stuff that gone down with the CAD team. I've been kind of not feeling kindergarten projects so a whole lot, so I haven't really been putting in a lot of time in between streams, but I think this is cool, and I don't know, I think the idea of adding the punch to it means that this could almost be a product that we could sell. If you got to the global market, we might sell dozens of them, maybe 24 of these. People might want them.
Titans of industry.
Yeah, or collectors or something like that, or mega fans or whatever. I mean, it wouldn't be not
from the point of view of like trying to make it more cheap to make. I wonder if you could do it somehow with less motors. I don't know how you could.
Well, it's only going to need a motor for the slide, and then probably a servo or something for the punching actuation.
Mm-hmm. There's a guy on YouTube. His channel's called Stuff Made Here, and he recently did this project with an iPad and the LiDAR scanner, feeding that information to like this handheld device that it actuated a bunch of pins that like touched the meat of the inside of his fingers in certain ways, so that it transmitted like wall location, etc., in ways that weren't
that's stuff made here.
Stuff made here.
That guy is insanely smart. He's one of those people look and you're like, that guy is. It's not fair that he got like such a big dollop of brains from the brain fairy.
Yeah, I think it would benefit if we're really talking about reducing the number of motors, which I think is probably not a crazy thing. It might be good to reach out to him and ask him, like, about making that kind of machine, or even any machine. I mean, if you're familiar with that sort of stuff, I'm definitely not with programming or anything like that. Sort of designing the mechanics of it is a little different, but not the electronic side.
Yeah. Well, I'm the same way. The good news, though, is that we've got plenty of people on the electronic side in this team, right? So yeah. But anyway, that's the idea. That's about as far as I want to take that idea today. What I kind of want to do is come up with a layout for that machine. And we talk about that next week, and just go from there. Because now I'm itching to start laying out discard changes and exit. See, I can just sketch and not mess up our work. And as it saves. All right, so we're going to come over here. The heck is this window?
You appear to still be in read only for some reason.
Yeah, I never reserved it.
Oh.
Yeah. So we're going to come into a new workspace, my collaborative workspaces, and we are going to go to MMXT. Shark. Do we have a assembly file? No, we do not. So I'm going to come over here. I'm going to close out of this thing. Discard and close. Go from the Music Box project to NNXT leader. File new. Guys, are you ready for this? We're making a new file for the MMX touring version. Are you ready? Here we go.
I'm not sure I'm ready for that.
Dude, updating SolidWorks Connected is brutal, man. Like, here I am looking through my task manager trying to find the one app that it needs me to close. No idea. Amazing. Okay, wait, let's try it again.
So it says, this document will serve and save to the skeleton development collaborative space. Skeleton development?
You got to change your... Oh, wait. No? Isn't that the old name for your collaborative space? Like
Yeah,
your
maybe.
original one?
I mean, I have it here. This space is called MMXT. All right, guys, we have now started the next version of the MR machine, completely without permission.
Sweet.
Yeah.
Sweet.
I really wish there was a way you could remove that academic version.
Yeah, I've gotten over it.
Yeah.
Because anything you touch is going to infect the whatever file you touch.
Right.
Yeah.
So we're going back. So Andre, you got the skeleton open in Fusion? Oh,
Yeah,
boy.
I don't know if you can still see my screen. I think you can. I wish. Oh yeah, because my share my screen is open there. That's right.
The
Well,
the question is, so on the in SolidWorks, we're going to start with the layout sketch.
Yeah, I think probably the closest thing I have here to a layout sketch is this, which is like sort of the squares which represent each instrument there.
Let's see. Why is it not giving me the... Oops. What did I just do? Show feature detail. How come it doesn't give me layout options on this menu?
Because you gotta
open
go
the layout. Right-click on your tabs at the top. Like any of those tabs, like Assembly, Sketch, Markup, Evaluate, whatever, and then just
Layout,
right-click
there
one of
you
them.
go. Oh, okay. You have to create the layout. Actually, you know what's weird? Wasn't layout in the... am I wrong, or wasn't it not like in the assembly? Anyway, doesn't matter. I shouldn't expect SolidWorks to not change in 10 years. And
Sweet.
Raphael, no, I'm not still a student, but I run a business incubator where I'm at right now, Inventopia, under this finger, is a business incubator that's partnered with UC Davis, and I'm on a workstation that Inventopia built. I built for Inventopia. It's my nonprofit I started. And anyway, it's a shared CAD workstation, and a student installed Student Edition SolidWorks on this machine. And so I am now infected. And yeah, that's just going to be. I can't keep that from happening. And anyway, so let's do this. So our origin, is the origin the center of the programming wheel, or is the origin at the floor under the programming wheel?
Well, if you're going to do it like we did it before...
Well, let's not do it the way we did it before. Let's do it the right way, which may be the way we did it before.
Okay.
I was the one that moved it originally. It used to be at the bottom left foot but I actually think it should be the center of the top. But
Center of the
I mean,
top.
if we're just going to start from scratch, really, you could really pick anywhere. I think
Right,
that
so-
it makes sense to be the center of the top, but any other place could make sense too.
You mean like the center of the middle of the programming wheel? That's not what you mean by the center of the top.
Oh, sorry. When I said the top, I meant the exact opposite of that. The base frame. So
yeah.
like XYZ0 is the top surface of the base frame itself in the middle.
Yep.
Yeah,
That's how it is in here.
I mean, I kind of think that maybe center of the programming wheel makes sense, but it also makes sense because, like, if you think about it, if we're looking at the left side of the machine, right, we're going to have the programming wheel. We're going to have. I need to stop looking at my OBS and actually look at my SolidWorks window. We're going to have a axis here for the muting system. We're going to have an axis here for the manual triggers. We're going to have the main crankshaft here, right? We're going to have some. We probably don't actually need to do this. We're going to have another wheel someplace over here. So we'll match up with that, right? So the location of all of these entities, we're going to have a X and a Y offset, right? This means, so like, where is that shaft located relative to the origin?
Exactly.
Right. So deciding where the origin is I think makes a lot of sense as a pretty important. Yeah, I mean, I kind of like, the more I'm thinking about it, and I'm open to being overruled if you tell me so. But I kind of like the idea of making the origin the ground and making it the ground point directly under the center line of the programming. Talk me out of it.
Interesting.
I like Andre's response. Interesting.
Never thought of that to be the origin, but I don't know. I don't think it matters.
Because then
to
we
me,
have a dimension for like how high is the programming wheel off the ground, right? All of the, at least the y coordinates in our thing are basically how far away from the ground is. At least the ground is an absolute point, right?
If you say so.
Yeah, I don't know. Is the ground the absolute point?
Talked out of
I feel like the bottom of the machine, and then you have just legs going down as far as you want.
So Jorgen is saying about the top plane is the bottom of the foot, which is basically what I'm saying. Front and right in the center of the base between the 4 feet.
Just remember, Joran, or however you pronounce your name, sorry, that this is SolidWorks and not Fusion. So the way that Fusion, by default, at least if you have an updated version, if you installed it a long time ago, you might still have it set the original way, but X and Y and Z are going to have different names in terms of top, right, and front planes. So, and then the default isometric, or in our case, trimetric view, if you look at it, it puts Z towards you. So I proposed a while ago to make all of the shafts that run across the machine be in the Z plane. And then, so we're sketching in X and Y, which is actually the front plane
right now.
Yeah, which is what we're doing right now. So that's my vote.
Yeah. But what he said though is he said the foot is the top plane, which I've now highlighted. Right. So that would be the feet, and we're dimensioning off the floor.
So he's proposing that we do whatever we did in Fusion, and I actually or the original model in Fusion before we changed it, and I don't like it. I don't like it for a number of reasons, but mainly because I like the foot isn't like, it doesn't have any like, the only relationship it has to any of the rest of the machine really is how long the leg is or how tall the foot is. Right. But that is something that is also up for debate, right? How tall it is or whatever. And that means that the rest of the machine becomes a variable based solely on how tall the leg is. And I don't know.
Yeah.
I think that
I don't
how
agree.
tall the leg isn't really important to the position of the programming wheel.
Yeah, but if it's parametric, then it doesn't matter, right?
I mean, I guess the way I look at it is that, we have a historic opportunity to right a whole bunch of wrongs.
Right.
And I personally feel like putting the origin at the bottom of the foot was a historic wrong. I think that
historic yet epic wrong.
Yeah, I think that putting it at the center of the top of the frame makes that relationship a lot more relevant to the mechanics of the machine in general.
I get that.
So,
I get that.
like, I'm actually curious where the origin of a car is, for example, if you're a designer of automobiles, because there are so many places where you could consider, like, the origin to be most important. Like, right, is it the center of the interface between the transmission and the motor? Is it like the rear wheels hub in the middle of it? Is it the driver's seat? Is it the middle of the steering wheel? It's hard to really say what, like, the origin of a car should be.
Yeah,
I'm sure automobile people know exactly where it should be, but it's an interesting question. I actually think that I made the right decision to put it in the top center of the frame. But you know what? I guess we should have this conversation. Maybe it should be somewhere else.
Is there any scenario in which we would want something to be symmetrical, like from the bottom of the machine to the top? Because that would be a great reason to put the origin at that location.
Yeah, no, not that I could think of.
I mean, I
When you
also
say
like
the
the top
bottom
of
to
the
the
frame.
top, what do you mean?
Well, just like, obviously from looking at the machine from the front, we're going to put the origin in the middle of it, right? Because then you can, reflect things on either side, like the two halves of the programming wheel, the two gears on either side. But
Okay.
so that's why I was wondering, like, if you think of it, the bottom to top axis, right? Is there another similar point of symmetry that we could leverage? I don't think so. Yeah, the machine's not super symmetrical in the top bottom axis. I mean, I'm with David. I think that putting it at the top of the base frame makes sense because then, you can use that plane to draw the outline of the top of the base frame from the top, for example, or whatever.
Mm-hmm.
Just extrude it straight down, or I mean, I'm not saying that we necessarily do that, but you
Take
could.
the planetary gears. All right. Well, hey, let's Andre, help me put in some starting geometry then. So let's define what's the distance between the top of the frame and the center of the programming wheel.
Well, so that should be definitely a function of where the drive belt goes and how long it is.
Well, the crankshaft would dictate that, right?
What do you mean?
Well, so the drive belt will go. I'm going to say that's just for now. Let's say that's 400 millimeters.
I think you're right. I think it was 400. But actually, it's interesting. That's a very good point. Maybe we should make the programming wheel, be the thing that we actually locate, and then have the crank be determined by the belt length.
Right.
I think that does make a lot of sense. So yeah, it wasn't like that with the original one. I'm looking at Andre's screen right now, and if you see all that mess up there, unfortunately, that was a huge archaeological expedition that determined where all that is, and all of that stuff is interdependent upon each other. It shouldn't really all be there, in fact, in this model, but it has to be because of how it was originally built in 2016 or 2017 by the subsequent people that have since worked on this, and it was kind of a pain, but unfortunately, all of that has to be in the skeleton for it to work.
Yeah, I didn't change this particular drawing very much from what you did, David, when you made it. So
yeah. But
Right, so
I guess now it's a good opportunity.
I needed to.
So give me
Yeah.
that base frame up to the center point of the wheel.
460.
Oh, I was decently close. And what's the? I guess I don't need to do the programming wheel diameter on my screen.
Which, by the way, is not in here, interestingly.
Well, it doesn't really impact that because this has to drive the frame, right? And the frame drives other things. If we, what is the diameter of the programming wheel?
Good question. Let's see. I will have to investigate that by looking at other parts.
Do you mean the surface of it, like the PVC panels, or do you mean like
just like a nominal, like if we're making this sketch?
Yeah, there's a lot of diameters to be had there, right? Because there's like the gear diameter.
How about this? What is the pitch diameter of the ring gear? Because that's actually relevant.
Yeah,
that's actually relevant to this because we're going to have other gears going coincident with it, right? So just Andre, just pick something like approximate because we're going to make this parametric and we can change it at any time.
Yeah.
So unfortunately, that was one of the things that Martin eliminated in his quest to make the thing smaller, the whole file.
Mm-hmm.
And that's why my argument about it being a fake gear kind of, I guess, went in a lot of people's ears and then out the other again because they didn't understand what you mean when you're looking at a gear. But in reality, when all you have left are like, the printout from Martin Wandel's gear generator, you don't have any, you don't have a fully defined sketch that tells you exactly what all those things are, then the center of that is anybody's guess, really.
Right.
Yeah.
So you could actually figure it out by taking the center of that gear, drawing a circle that's not defined, and then drawing a center of another gear that interfaces with it, and then not defining that, and then making them tangent to each other, and that will tell you what it is.
Right. Well, that's kind of what I'm thinking, right? Is that if we have this, we're looking at the left side of the machine, right? So we have the Wilson gear right here, right? Its pitch diameter is going to match this one, right? If we know the pitch diameter of both of those,
I can get you these numbers in a second. Oh.
If we know the pitch diameter of both of those gears, then we can kind of locate. We just have to pick the angular location of where that little smaller gear is.
Uh-oh. Andre's computer is going crazy again.
Well, I have to look.
It's working. It's loading the master assembly. This is the thing that takes time.
Is this because you're having it do SolidWorks and Fusion at the same time?
Oh, absolutely, yeah. Gotta give my computer a workout. It'll happen eventually. I'm not concerned that it's crashed right now.
So while he's finding
but
that,
once we get it, we can get all the dimensions
which is set by this. We have a vibraphone shaft, right? What else do we have to locate? We have the muting system. There's a cross axis that the registrators pivot on, right? That's different than the muting system shaft.
I wish I had it open in front of me. I could tell you.
Let's look at Andre's.
I wonder if I can export it in a way that you can import. That would be.
Oh, so is open it up in SolidWorks? Where's the fun in that?
Yeah, I mean, well, I would love to click on things for you, but we got the wheel. Okay, here we go. So what do you want? You want to distances from here?
Well, so yeah, what are the things that we're locating, right? Because your skeleton also includes part of the frame and stuff like that, right?
That's a lot.
Yeah,
random stuff in it. Yeah, correct.
And I think we don't care where the planetary gears are, right? For this first sketch. But like, we have the things
So
that
like,
go across. Like, what are the features that we are? Yeah, zoom in on that, right? So that shaft for the muting
like
system.
this,
That's an important one, right? And
yeah,
then the shaft
and
for
okay.
the actual fingers.
Well, part of the machine, possibly the most important part, is absent here. The part that actually touches these.
Yeah. The triggering mechanisms.
But I guess, let's see. Guess that would be like here. I'm not sure what this dot is about at the
That's
moment.
the center of a pivot that interacts with that hook there on the.
Oh, that's true. Yeah, because the pivot has to go over this slope here. That's what that's for. Right. And that's not in the model because that would be in the sort of marble divider assembly, which is not in here right now.
Yeah, exactly.
Okay, so but what you want is like the location of this shaft, let's say, right? And let's see, is that actually in here? I think it's this. So how do you want to position that? I guess from the bottom we have 935.96, which is
Wait, is there no way to overlay that to?
There probably is. Let's see. I bet I can just derive it in here probably. Let's see if I can do that. Or it should exist already in one of these. Oh, it is in here, but I can't make it visible.
Really? Why not?
You have to edit the part
Well,
to make
because
it visible.
yeah, so this is why I do like you have to edit in place and then make it visible and then save it. It's the way you do things.
Oh wow.
Now that I've gone, like, because I'm doing this thing for the medical device company that I'm working on right now, I'm doing all of that kind of after hours at home because I'm just doing it at home because I have 2 children and it's COVID, and so I spend a lot of time at home when I'm supposed to be working.
Yeah.
And now that I've been reminded of how easy it is to work with different files and different levels of assemblies in SolidWorks, the thought of continuing to work on the MMX in anything other than SolidWorks almost angers me. Just like, like I want to open this file, I want to look at this assembly, I want to just be able to open this part easily and not deal with just the way that Fusion nests and has these weird dependencies. Like, oh, if you export that, then you're going to lose the feature tree. Like, what? Like,
well, so a lot of that is user error. Actually, I sympathize with you for sure, but the thing is, I've learned a lot more about Fusion and what not to do on this Marble Machine project, really, than I care to admit. But the truth is, so much of what I've discovered is that there's a lot of folklore, and I've said this publicly a lot, but there's a lot of folklore around Fusion and how to use it that works fine for a bookshelf. If all you're doing is making 5 pieces of wood and a rabbit cut, just knock yourself out, have fun, do all the things that people talk about when they use Fusion on YouTube and stuff. But for a machine like this, like you just have to go at it from a completely different way. And I tried to change a little bit of that culture early on in this remodeling project at the beginning, but and you guys have really taken off with that, which is really cool. But so many of these of the models that have gone out to the community, they come back modeled exactly like we started with, right? And you end up with these weird interdependencies that you shouldn't have. And unfortunately, a lot of that is just the fact that the way it was built in the first place, there are so many things that aren't even on the machine anymore that are the parents of so much geometry that comes down from the top, that it's just, unfortunately, a lot of these interdependencies just cannot be eliminated because they are a requirement of the design. because of how they were designed in the first place. And one of those things is the placement of gears and all that stuff, which is really too bad.
Yeah. Well, yeah. So we want to avoid that, right? So
Yeah.
it's by making this master skeleton that we're talking about right now. So
Exactly.
So let's.
But it's not just having a master skeleton. It's also avoiding dependencies in that skeleton.
Yeah. So as we make the parts, there is discipline about where you take your references from, and et cetera, right?
Right.
And I think if we're going to come up with something that's new and I think we're going to be going back into the skeleton to add references as we make new assumptions, right? So anyway, so getting back to the primary question. So Andre, it looks like you have a pitch diameter for me there.
It seems like I do. I just can't understand why it's blue. It should be black if it's right.
All right. Well, if it's blue, what's that diameter?
Yeah. See they.
So we just try to pick up a spot that's even distance between the two gears, right?
Yeah, I think that's fine. Pretty much all you can do, really.
Yeah.
Look at that.
Okay. Yeah. So what do you want? You want the big one?
The big one first, yeah.
Yeah, we got 449.46.
That's the radius?
I would say that's a 900 millimeter wheel. I would say, just looking at that.
Yeah, seems fine. Yeah, that's a radius. 900 millimeters seems good to me. Okay, so then let me just set that, and then.
What about the side to side wheel? What do we call that one again?
What do you mean side to side wheel?
The combination shaft, or the one that it's basically sitting on underneath. It's in the frame. You were just looking at it.
Yeah. This one. This one is 56.2 radius. I guess 0.202 if you want to be exact.
So 100 millimeters?
Well, if you make it 100 millimeters, then it won't match perfectly with the other circle if you keep this spot, but you don't have to.
My guess is that 900 is going to be your driver, and the other one is going to be a factor from that. I think it's probably, if you do the math, whatever 900 is divided by 112.4. That's probably a factor.
Mm-hmm.
So what number am I entering for that?
Well, it's kind of 8-1, but not really. But that's another reason that I wasn't really a great fan of Matthias Vondel's gear generator. So it's 8.007117.4. So I think it's supposed to be an 8-1 gear ratio.
An 8-1 gear ratio.
Yeah.
So then I'm in. Let me do. So over here, how do I in SolidWorks? If I have a 900 millimeter pitch diameter, can I literally do?
So you go press equals.
Yep.
Now you definitely want it equals, because if you don't do equals, it's only whatever it is now.
Right.
So no, you gotta get rid of it and then press equals. Just back up. Just delete everything. No. Just delete everything. Delete everything.
Okay.
Now, what if we just make these gears the same? Aren't they the same? I guess they're not.
All right. So I'm going to hit equals this divided by gear ratio.
Yeah, equals. Now go up. There you go. Select that. Boom. Now divided by 2.
Divided by 2.
Or sorry, not 2. What am I talking about?
8.
Yeah, gear ratio. If you made the gear ratio a global variable, you can probably do that now if you want to add it just by. Yeah.
I'm gonna do the tools. Come on, where's my equations? No. Do I have to exit the sketch to add a new variable?
No, you can actually do it right there. I thought we were doing that, but you deleted everything.
It didn't like it. Equations. Here we go. So right now I have the programming wheel pitch diameter, the layout. Yorin is saying external references in machines like this is never a good idea. Is he talking about? I don't know what he's talking about. I'm trying to avoid Yorin external references at all costs. So we're going to call this.
We're gonna have. I mean, if you make a skeleton, everything has to reference it, right? So there's your external references.
Yeah.
So like, you kind of have to.
Oh, you have it in a weird method. So if you see there's 4 boxes at the top underneath the menu or underneath the top line.
Yep.
And one of them has like a Sigma and then a sketch icon, and pick the one that says Sigma. Yeah, that's the one I would normally want to see. And global variables is where you enter it.
Okay. Compound shaft gear ratio.
Yeah. So the one that you had selected, it's called solve order, which means you have it listed in a way that SolidWorks would solve it. And you can, I mean, there might be reasons why you'd want to do that, but in this case, just entering global variables like in this screen is probably better.
Yeah. All right, so it's going to be 0.2. That seem right?
Well, 0.2 is 5 to 1.
Oh, crap.
I would just say use a number, 8. Like, if it's 8 to 1, just put 8.
Yeah, and if you actually write like 1/8, I think it'll keep that, right?
It depends if you want to multiply or divide in your equation. You could do either one.
Yeah,
if you want to multiply,
when I put in 8, it gave me inches. We want this to be unitless, right? So, all right, I'm just gonna try that. Let's go here. Layout. This is going to equal this variable divided by, what did we just call that? Compound share. There we go.
Well, no, because you're multiplying it. Remember? Because you did a ratio already in the variable.
Yes, thank you. I forgot that I did that.
See?
Math is my friend.
Bit in the ass immediately.
That's why I would prefer to use an integer instead of a fraction, but whatever. I guess,
Yeah.
Potato, potato.
Oh, you can do tangent. Good. Okay. All right. So, is this wheel though is not directly under the center line, right? It has some sort of offset in this direction.
Which wheel? The one you're touching now?
The compound shaft axis.
Yeah, the center of that is the middle of the top square tube.
Yeah, so let's do that. Andre, you have that up?
It's 20 millimeters, I'm pretty sure.
This is one thing that bugs me about this, right? Is that obviously that shaft was placed there because that was the center line of the tube, but then he jogs the frame around it.
Yeah.
Yeah, so then it doesn't even matter.
I mean, it would almost be better if it wasn't the center of the tube. So let's actually have a high-level discussion about that front plane of the top of that and how those bearings work.
Mm-hmm.
What would be the better way to do that? Pillow blocks on top of the frame or dangling from the frame? I mean, how do we do this so that you don't... Or are those jogs in the frame, which do not make sense structurally, by the way.
Yeah, agreed.
Are those an aesthetic thing, or how would we not do that?
I think from the perspective
on that, Andre?
Say what?
Can you rotate your view a little bit?
Yeah.
From the perspective of a touring musical instrument that has to fit in flight cases, etc., I would say that the entire top section needs to come off the base. And so I think it makes sense for them to sit on something that fits on the top of the frame in some way.
Yeah.
So I like your idea with the pillow blocks fitting on the top. I don't, maybe that's something we can flesh out, eventually, but
Right.
we can place the shaft, at some prescribed place that we can, control as a variable.
Right. Well, I mean, so the
Or
question,
below
the reason I'm asking the
the
question
thing would be
is
good
that
too. I think.
here I have a blue circle for this compound shaft, right? If I wanted to constrain this, we just said, okay, it's coincident with the middle of the frame, and we have a line for the middle of the frame, right? But that is not that's not written in stone, right? I mean, it was obviously placed there back when they thought, hey, I'll have this shaft going through the frame, right? But then he modified the frame to go around it. It looks very much to me like the frame is modified to go. It probably is in a video. You probably find the video reference for that. So I don't want to constrain this point here in the middle relative to the top of the frame just yet.
Yeah.
Because if it isn't a pillow block, it's going to be down here or up here. Or if we go straight through the frame, then we're thinking of anyway. So let's think about that.
I'm pretty sure the way I handled this in the skeleton was that I made a parameter for the thickness or the width of the tubing, and then I just made the offset of that shaft half of that away from the origin, which is another good reason to make the origin the top. So you can make that like a global variable and then just change it when you feel like it's a good time to do that, like when you have a better idea of how it's going to be built.
Yeah,
I think that the most important thing probably to constrain would be like the ratios of these things, right?
Oh yeah. So you have. Oh. Can you turn on the model again?
Yeah.
By the way, on a side note, I think that the touring model's probably going to rely a lot more on belts than it does on plywood gears. Just FYI, I mean, for practicality.
Right.
Yeah, that seems good. Like a good idea.
Well, that lower ring, right? That's not coincident with the compound gear shaft, right? Can you show me the left side view straight on again? Right. So, it is. It is. Okay.
Yeah. There's the two shafts are represented in this. So these are the two shafts here.
Yeah.
Right.
I'm pretty sure those two shafts are a specific distance from each other too. I can't remember what it was, but
he actually had to change the depthing of that compound shaft when he was one of the episodes where he was kind of playing with the resistance. Because the upper wheel was kind of sitting on that compound shaft that goes across. So, one of the reasons to not
do that,
have that axle be right in the middle of the frame is the ability to depth that gear and make that adjustable.
Yeah, I mean that's definitely a good reason. I think. I remember the episode where he decided to, depth the, and he's actually talked about this in more than one episode, but depthing the planet gears, and I'm like face palming because I'm like, dude, you can't depth planet gears.
Yeah.
Like they are or they're not, but that's it.
Yeah.
Yep.
All right, so
and he ended up, I think, remachining them actually, if I'm not mistaken.
So Andre, you had a sketch with the MRL1 gear and then the Wilson gear. Can you give me those sizes?
Sure. So the gear in the end of the crankshaft is 46.25 radius.
I
don't know how well you can see my screen. I can just make these little call outs so that you can just look at it.
What do we call that guy? That's the timing gear? It's the gear that's attached to the timing clutch.
Yes, that's right.
All right. Sorry, I have to enter the number first. What's the number again?
Yep. 92.5 diameter.
Wait, so are we recreating right now in SolidWorks what we already have in Fusion? Is that what you're doing?
I mean, what I want to do is I want to at least have some things basically to scale, right? But then I want to make them parametric, so that if we say, okay, does 92.5 pitch diameter work? No, let's just make it 90 or whatever. Like I want to make it. I want to basically kind of get the original the relationships the same, right?
Got it.
Let's think about it. So if we are going to design this, right, there's a good chance that we almost have to do this on a rogue basis because Martin is not going to have the bandwidth to babysit, the design of the MMXT, right? He wants to, but I think realistically, we have to assume that we will, be doing this and then asking for feedback and have to be independent, but also be ready to make changes, right?
Yeah.
Yeah.
I get it.
So, should we do this based on gear ratios again instead of doing the diameters?
Yeah, we're talking about gears. I mean, honestly, I think using one, master sort of gear as the size, and then going into gear ratios makes perfect sense, or at least figuring out which one is the master. In this case, it's very clear that it's the 900. I mean, it's a.
Yeah. But
that was obviously the first number.
The first marble ring lift gear and the timing clutch gear, is that the same ratio? It's got to be, right?
It's been a hot minute since I've looked at that stuff. I think Andre would know that more than me.
Yeah, so here I have the ratios that I programmed into the motion links here. So from the crank to MRL1 is 1/8, and then from the MRL1 to the programming gear is another 1/8. So it's 1/8 twice, I think.
Oh, okay. So I can reuse that variable in SolidWorks a couple times.
Yeah.
But so what does that mean? Those ratios are 1:8, but that doesn't mean the MRL1 isn't the same diameter as the larger gear, is it?
Yeah, so I think that's like a ratio of the shaft rotation. So this shaft rotates 8 times, this shaft rotates 1 time, and then when you compare this shaft to this shaft, right, it's another 1/8.
Yeah,
that's what that means.
So you see what on my screen here now. Like I'm just trying to think, like, how do we set the? I guess the size of the MRL1 gear, that pitch diameter doesn't matter, right? It just matters that the clutch is in a 1:8 ratio, right?
Yeah, I guess that's tricky because the MRL1 gear also lifts the marble, so you do want the diameter to match for that, and that's not incorporated into these numbers. However,
but it's not mechanic. It's not
all
like
you're doing
drive,
is doing
right?
1:8 from here to here. So really, that's the only thing that matters. So if you were to put these shafts closer together, for example, then this gear would be smaller.
Yeah.
So
let's start with the diameter of the MRL1 gear, and then drive the. Actually, no. Well, if we've already done this gear, all I'm saying is we got to define the pitch diameter of one of the two gears, and then drive the other one off it. So is Wilson driving it, or is the marble ring lift gear driving it? I think the bigger gear should be defined.
Yeah. I think if we're gonna go with the idea that the gears are lifting the marbles, which is how it is in the machine, then maybe the large gears should have their radii defined, since they're also used for the marbles, so that's important for that. And then the smaller gears should be based on ratios, which is
give me a pitch diameter for the first marble ring lift gear. Pitch gear of the
that would be 740 diameter.
740.
740 millimeters, I think. Yeah, definitely everything's millimeters.
So I'm gonna call that equals MRL 1 underscore pitch diameter. But that's a plus underscore. Come on.
Actually, you want to press enter right afterwards, and then that'll save the global variable, and then you can finish out the Yeah, you see how you've got that plus sign next to the global variable there? Just click that. Oh, no, and it just...
I fixed it.
No, you didn't. If you back up, like backspace... Oh, never mind.
The delay.
That's okay. You can create the global variable while you're here.
That's what I'm doing.
So if you do equals...
Yeah, equals.
Yeah, so... Yeah. Okay, there you go. And now you see that glyph shows up? That you don't see it there with the globe and the plus?
We're good.
Yeah, you click that and you make a global variable.
Yeah.
Boom.
Did it. Yeah, so now under equations I have MRL pitch diameter is 740. Now this guy is going to equal that times gear ratio. Yay, we're parametric. I need a golf clap soundboard thing.
Yeah. You need to get your streamer soundboard going on.
So now that we've done that, right? We have the actual dimension for the center of this compound gear is annoying because it drives the location of some major features.
Exactly. It's super interdependent. So you have to figure out what's more important, location or size in some cases.
Well, we're going to need both, right?
I think what's important is how the marbles are getting from one gear to the other. So if we're concerned about like the angle of this ramp that has to go over here, then perhaps that should be the thing that kind of limits us in terms of where the gear goes.
Oh, yeah. Angle of the ramp, though.
I don't know if it matters because, the gear's pushing the marbles in there.
Yeah.
Wait, is that what you're drawing now?
Come this way. Well, but they come out and then they loop around, right?
Yeah.
So you can pick the pick up and drop off points almost anywhere. How about we define the center of this as a Y offset relative to the top of the frame?
I think
that way, if we're using a pillow block on top of the frame, it's one number.
Yeah.
If it's below the frame, then it's a negative number. And if it is, let's try this. If you do this and then you change it to 0, will it actually go parallel? So right now it's 30. If I change that to 0, will it go? Oh, it does. So let's call that equals compound shaft Y offset. Done. New global variable. Now we're defined there and there. And you guys want to meet my oldest son?
Sure.
Just showed up.
Sure.
That's Jack. You're on YouTube, Jack. Hey.
Hello.
All 7 people who are watching are saying hi. It's funny because Maureen was like, she's like, does not want her kids on screen, and and my kid is a little more gregarious than that, and I, anyway, I worry about more things. So we have these two and then we can people are saying hi to you in the chat. So is this have to be horizontally perpendicular to that main shaft?
No,
timing?
Not at all. I think that the position of the crankshaft call it the crankshaft, even though it's straight, but that's what the crank's on. Doesn't matter at all, right? I mean, I guess the only thing that it does matter for. Okay, wait, maybe it does matter. It matters because that's what the
switch to
rhythm
your
machine
screen.
is on.
Yeah, there's a lot of other stuff that crank drives than just the other wheel.
Yeah, can you show us, turn the frame back on, Andre, in your view?
Yeah.
Oh, man, this machine.
Let's get the 3D mouse going.
So, I mean, they both go right through the frame, right? So that's why they're currently, distributed along the top of the frame. I guess whatever we did for a bearing, well, no, because the crankshaft does not need to be, or does it? Does it need to be depth with regard to the lower gear? It probably does.
I'm not sure I understand what you're talking about.
So once you manufacture the gears, you need to change the axial offset, to get the gears to move to depth to sync up, right?
Yeah. And I think the way that Martin did it was just by making these teeth the wrong shape.
Yeah, exactly. I mean, there's no way to depth his design right now. That's just not a thing.
Yeah. But if you had a pillow block and it was on top of that rail, right, and it was fastened,
and then you could just move it along here.
Yeah, I actually think that this is a perfect application for a belt instead of interlocking gears. You still get the effect. You just, I don't know.
But the gears are such a primeval visual, aesthetic of this thing.
Yeah. Well, I mean, so
if you have a sprocket, you still have the gear effect, but
yeah,
sprockets.
The thing is, for it being a touring model and having to be disassembled, you can't depth the gears every single time you put the damn thing together.
Yeah.
Well, so between that big lower gear and the crankshaft gear, right? You do that once, right? Those would stay on the base module. You could do the depthing between, if the top pulled off, you could do the depthing with that based on like a set screw, something that basically holds changing, or some shims or something that you just kind of figure out, or you grind it, the surface, until when they come down and they bolt together in position, they are always right there. Right?
Yeah, I mean, that big marble lifting gear, I mean, man, it looks really cool, and it really would be a shame to have to take it off. But like for touring, I just don't see that gear staying on the machine when it's being transported. So maybe it can be removed at the hub or something, and then it doesn't matter, But
I don't know. I mean,
currently you can remove these 5 bolts and then get the whole thing, get the big gear off, and leave the smaller gear on.
I mean, Martin's already kind of said that he's kind of given up on air freight for this thing, which means that to transport it, all you have to do, and this is, by the way, I think a kind of a key design requirement for this, is to make it palletizable. Right.
Well, right.
So, and just we develop a crate that it goes in, and you can leave it as we can leave it as assembled as we need to, provided that it fits into a high cube semi trailer or a shipping container if it's going to go across the ocean.
Yeah, you say that, but I mean, how many times have you been in a concert venue in Europe where the streets are like...
I've never been to any concert venue in Europe.
Okay, well, I can tell you that if you go to the kind of places where a Swedish marble machine player would play a concert...
one of many that I know of.
There's going to be a lot of places where you might have bands show up, but they probably have to roll their equipment down a cobblestone street for half a mile because you can't get parking anywhere near the concert venue. I mean, I don't know. Maybe his experience as a touring musician would say otherwise. I'm just thinking that I've been in a few bars in my life and seen bands and stuff, and one of the main problems he had with the original marble machine was that he made it wider than a door, right? And that's genuinely an issue.
Right.
So
do you think he's going to be playing bistros and cafes, or is it going to be touring stadiums with loading docks?
Well, probably I would say a little of both. Honestly, touring musicians play all kinds of venues. Yeah. I don't know what his future is. I don't have a magic ball.
Yeah. If you did, you'd probably have more money.
And a better milling machine.
And a better, yeah. You wouldn't have to suffer. You have a shop saver instead of that Shape Oko thing you bought.
Yeah.
Okay, so let's go back to the SolidWorks part.
Wait, are you talking trash about my Shape Oko?
No.
No, not at all.
I don't actually mean it.
Everyone wants a better machine. I'm just assuming that's just a thing.
What's a better machine? The
shop Any saver? Machine that's better. You always want a better machine, right?
Yeah. So I didn't know about shop sabers. A friend of mine built basically a robotic furniture factory near here, and they have I think like a Cat 30 taper and an automatic tool changer, like a router that has an automatic tool changer. I was like, that's the coolest thing ever. I design my parts around not having to do tool changes when I'm using my router. It's just like I design it so I don't have to change tools. All right, so what's our other key geometry, our other big geometry that we have to worry about in this model?
Yeah, I was thinking about that. I mean, I think that the rhythm machine is important, and it has to fit
the axis,
produce the right
machine?
timing. Yeah, just like the fact that this thing is here, and then this has to be on that shaft that we were just dimensioning.
Hold on, I'm not on your window.
So like probably, yeah. So that seems kind of important to me, but I don't know.
Well, no. So we don't have. I'm still talking about from the left side view, right? Let's try to locate the shafts that go across.
Okay. Yeah. Sure.
So, what are the other ones? We have the muting system locations.
Oh, right. Okay. Sure. Yeah.
And then the trigger. What do we call those shafts?
Oh, so I guess we have this. This is the pivot shaft that the registrators are on. That seems pretty important.
That's pretty important. So registrator pivot shaft.
It's like, yeah. So because the other things over here, I mean, you could just make this piece longer to change whatever dimension you want over here on the right. But this pivot over here is critical.
Yeah, most of the stuff in the middle there has either been eliminated or is a completely different thing than what this machine was designed with.
Mm-hmm. So if you want this position of that thing from where, let's say from the origin, right? That's what we're talking about.
Well, that's a good question, right? So we have it's always going to be some distance away from the, I know that we don't have the center of the programming wheel at the origin, but we have it defined tangent to almost tangent to the origin. So can we define things relative to the center of the programming wheel?
I think this particular point is definitely, a straight line from the programming wheel, right? Well, is it? That's a good question. It should be, right?
By the way, so there's some questions in the chat saying magnets not being used on the touring version, and yes, Martin said that several times. That we wouldn't be using magnets in the next version. But I think what he's talking about is the ones where there's a hole. There's holes in the perimeter of the machine, and the balls will fall into the hole and then get transported up and then pop out of the hole. So the diameter, the construction of the wheel is different, but it would still be a big wheel. I have a feeling. I don't think he's planning on changing that kind of form factor of having two wheels lifting. I think it's how the wheel holds the marble is changing.
Well, and actually, if you had the holes, you could do something where it just falls straight out of one wheel and into the other, and then you don't need this little what is this thing? This thing, you don't need this.
Right.
Which would be nice.
Yeah. All right, so we're going to try to look on my screen. I'm going to try to locate this point. Oops, I keep on looking at OBS and trying to scroll my mouse relative to OBS. Trying to locate this point for the registrator. Should I do that relative? I can do that relative to the origin is underneath the center line. So this, yeah.
So, one thing to consider, I don't want to gum up the works, but if you think about it, the location of that shaft is obviously driven by considerations of, the what do you call it? The registrator fingers themselves.
Yep.
And
yeah,
the registrator fingers themselves were placed there because of all of that mechanism that was originally designed between it and the actual lifting fingers. And all of that is virtually gone. My personal opinion is that those registrators don't have to be that high up on the machine anymore. That's just my personal opinion, and this is kind of a wild idea, but I actually think that whole thing could just be right behind, where Andre has his mouse right now.
No, yeah, that's what I was just thinking of that, because this is where the drops happen.
Shout out to
matter
Connor.
of fact, this is where the drops happen actually, so why not just have it right there?
All right.
Yeah, like it could be somewhere in that region, and I just think that, we could either design it that way or just keep an open mind, or I don't know.
Yeah. I mean, how crazy are we going here with the redesign? Because I mentioned this in the MMX community channel, but like, if you don't want to have all these mechanical linkages that have to be in a specific spot, you just use Bowden cables for all the registrators, and then you can put stuff anywhere. Basically. You know what I mean? Like have little cables coming out. And then you're very free to design it however you want. You don't have to, try to jam in levers and stuff.
It's yet another one of those places where it's the engineering and the aesthetics overlap and collide, right?
But if what you want is you want to have these levers up here in the corner. Oh, that's not the one I wanted to do. Meeting system assembly. If you want these, you can still have them. Then you just have little cables coming out the back instead of these things, and these can be anywhere, right? So I don't know.
I mean, I actually kind of like the bistable mechanism. I don't even think that's too complicated, is it?
No, I think that can stay.
And I know that he really likes the audio ka-chunk. I think he was talking about putting a mic on the bistable mechanism to capture those sounds.
At some point, every part of the machine has a separate contact microphone on it.
Yeah.
which I guess is fine.
He's got probably enough channels built in now for that.
Yeah.
But, I mean, again, I was just trying to introduce the fact that those registrators don't necessarily need to be there. The only reason they were there is because of this hugely complicated mechanism that the machine was originally designed with.
Right, the great
that doesn't exist anymore.
Yeah. All right. Well, so for now, if we do this, I'm just going to do an offset. Can we do a radial offset, like between the center of the programming wheel and the center of that pin?
Depends on how you want to do it.
Offset, or I could do a radial offset, or I could do an offset from the. Well, it's not from the surface diameter of the wheel; it's from the pitch. That circle, that 900, is the pitch diameter of that wheel, right?
Right.
So it has nothing to do with the surface of the thing, so I wouldn't want to link that way.
Yeah.
Let's do it.
I see what you mean. Yeah, that works.
Delete. It snapped the wrong way. Come on.
Tom Nelson says, if you don't use magnets, you could use 2 stages of gears. I mean, that is how it is now, right? There's 2 stages of gears. I'm not sure exactly what you're talking about.
That's kind of bizarre that it won't let you measure that.
I think it's because I had a dimension on it before, and then I tried to, and then I deleted it.
Well, so
I think it's glitched.
you know, one thing that SolidWorks does really well is tell you how to fix something. Like, for example, if you make it driving and then break it, then you can go through a set of fixes for it,
right.
And SolidWorks will walk you through it.
Yeah.
That's cool. On the topic of the lifting wheels, I was thinking right now, actually, that the way the machine is set up currently, these wheels are sort of overlapping, like they look like a Venn diagram. But if you have holes in them, then they don't have to. They can just be tangent, essentially, because then right at that point where they are tangent, that's where the marbles fall through into the other gear. So you could make it either taller or make the gear smaller, or just do whatever you wanted
so
there.
You're saying if the MR1 gear is a smaller pitch, so that the holes as they come past line up, and you transfer the ball over at that point.
Yeah, I think one of the constraints of the marble machine
timing problem to solve.
Oh, is it?
Because the holes are only lined up exactly coplanar, right at the same point. If you have a hole coming around, let's do it this way, right? So if you have,
no, if they're different diameters, that's true. Yeah, that would be interesting.
Yeah.
Okay, maybe not. Maybe we shouldn't do that. Okay, maybe that would be a recipe for disaster. I was just thinking, so one of the other constraints of the machine is how high you can lift the marbles, right? So right here at the bottom of this wheel, that's the lowest that marbles can ever go. So basically all the stuff that you're doing with the marbles has to happen above a certain point, and then all the sort of collection equipment has to be below there.
Yeah.
And so that kind of limits how much you can do with all the tubes, the total height of the machine.
Right. All the marble tracks have to be underneath, above that lower brace, basically. Do you think that's a functional constraint? I don't think that's a problem.
It's not a problem. It's just that is something we should keep in mind when we're deciding the size of this gear. So if we're going to say that this gear is smaller, we can't make it smaller than, like, this part,
right?
For example.
Oh, I see. Yeah. There's a functional limit, and that's not something we can do parametrically either. Yeah. Okay. Well, we're getting towards the end of the stream, and I still have located like 5 holes.
That's okay. I think we've talked about a lot of stuff.
Example of, like, don't actually CAD in real time on a stream, because you're not productive.
Yeah.
So let's locate the front, the triggers, the only parts that I know a machinist who hasn't gotten angle grinded. All David's parts up there at top. That shaft. Nope.
It's empty right now on his screen.
Yeah, I'm trying to remember. What is this?
Well, the shaft that they go around, is it different than? No, it's that front shaft right there.
It is. Well, it's this shaft. It depends on what you mean by shaft they go around. Because this is where the kinetic finger shaft is.
I actually didn't realize that there's 2 shafts in that location.
Yep.
So how do we define those? There's a distance between the centers of those? And
well, those are positioned on this arc here. It's kind of hard to see. I'm going to switch to the so there's an arc here, and these are the 2 axes that we're talking about here.
Okay. So I want to try not to draw the frame. I want to try to give the positions of the shafts without drawing the frame. So
I think that's
between those 2 shafts.
Yeah, totally. It is 100.859. So, might as well be 100 as far as I'm
101.
concerned. Sure. I don't see any reason why it can't be 100 though. Just looking at this. But
Well, it's on the arc. I mean, you're measuring
yeah,
a chord.
true. Yeah, that's right.
Well, I want to define
Sadly,
it.
you
If we
can't
look at
do arc measurement.
if we look at it on my screen, I want to define the length of that line as. Gosh, why does it do that?
Do
I tried
what?
to dimension that linearly, and then it snaps to an x offset.
Yeah, you just have to do the number while it's not like that. Like, yeah, there you go. Or I know there's a delay, so you're not even doing it when I'm talking.
No, but see, when I click it up there, then it goes to this other one.
Well, that's bizarre.
That's
so
really annoying.
You're saying it's just refusing to do that?
Yeah.
Okay, I don't get that.
Yeah.
Do you have any other
annoying.
constraints on there that are causing that?
Nope.
That is bizarre. I have to admit that I've never had that problem. So I would have to investigate how to prevent that.
All right, I'm gonna just exit the sketch and come back in.
What you could do is make it vertical or horizontal, and then do the same kind of thing, and then remove the constraint, the vertical or horizontal constraint. That might do it.
But the dimension will still be in the vertical or horizontal sort of regime, right?
This is one way to find out if it does it. Try to do that. Constrain it in some way using vertical or horizontal, and then dimension it, and then remove the horizontal vertical constraint. See what happens.
Oh, so do okay, I see what you mean. Nope.
Nope, it didn't fix it. Okay. I was just curious if that was a hack, but
that is maddening.
I
mean, because the other thing is, I did it here.
Yeah, I know.
That is All right. Well, I guess we're doing. I'm going to constrain them this way. So this is. We'll just enter some numbers for now. We'll figure out what we name these in a second. Again, relative to the programming wheel, I think is appropriate here. I wonder if now I can do the diff. Nope.
It's annoying that you can't change how the dimension is oriented after you draw it. There should be a way, right?
I've never been able
Center
to
dimension.
change the. Well, actually, no. Can you do it over here in these?
You might need a construction line to do that. Have you tried that?
Yeah, well, that's how I had it before. I had a construction line in between the two of them.
Huh.
That's how I was trying to force it to do that the first time, because then I was dimensioning the line. That is maddening. All right, that's not very entertaining. SolidWorks content.
I have a hack for you. Do it
so I can tell you, Tim, that the way I would usually solve that, that there's a different a different outcome between if you put the dimensions inside between the two leading lines or outside of the two leading lines. And one dimensions it vertical or horizontal, the other one dimensions it in general. So if you try that again, make it a horizontal constraint, and then measure it like the way I explained it, where you do it so that the measurement itself is outside the leading lines?
I think the trick is just to place the dimension very close to the line. I just zoomed in and it worked for me.
Yeah, there you go. Now add a dimension, but put the dimension box outside of the leading lines. You'll see what I mean once you do it.
Outside the leading lines?
Well, yeah, don't do the point to point. Do the line.
Put them
Get it?
out there?
Okay, now move your mouse to the left or the right beyond the leading. There you go, like that. Now click it. Right, now remove your horizontal constraint and it should work.
Doesn't work. Boom, boom.
What?
All right, well,
Okay.
we're breaking SolidWorks. It's 3:00.
Yeah. Well, I don't know, man. It worked for me. So.
Yeah. All right. So next week we're gonna go back to the hi Jack. We're gonna go back to the music box, and maybe let's make a list of the really important features we want to dimension in this view, and we'll continue with the Marble Machine X skeleton development. We got 2 shafts located today, and 2 gear and 1 gear ratio. So yeah, go team.
Yeah.
Most unproductive CAD session ever. All right, guys, that's it for this week. Until next time. Peace, says Jack. All right.